This is 3.1, day 1, part 2. We're going to use a graphing calculator just to practice some of these questions and identify what happens with these transformations. So we're going to take the calculator out. So let's go ahead and graph the first function. Y equals 2 to the x power. So with your graphing calculator, turn your calculator on. Make sure your window is set for standard. It makes it easier to view. So like standard window would be x values from -10 to 10 and y values from -10 to 10. Okay. Go ahead in your calculator, go ahead and put in y equals, should be there, and then put 2, and then the caret symbol, the upside down b, and then raised to the x. And we're going to see that exponential function. Then on the same graph, we're going to graph what happens when we change the base. So we'll do y equals 3 to the x, and then y equals 10 to the x. Yep, so I'll kind of help guide you through on my calculator too. You don't need to write these in your notes. So go to your y equals. You would put in 2 raised to the x power and then graph that. And you'll see that exponential function. Now if you go back to your y equals button and you scroll down and then over, you can change the thickness of that line to different scenarios. I'm going to have it as a it's a dotted line. Okay, there's a thicker line. Now we arrow back over. We change the base now to 3 raised to the x. When we graph it, the thicker line, it's really not touching the axes right here. It's a little bit distorted. Then if we go back to y equals and go down one more, and I'm going to change that to the dotted, so you'll see the dotted over here. You have to keep changing it. If we change it now 10 to the x, what happens as we increase our base, it gets closer to the y-axis, it increases at a faster rate. It starts off slower and then increases quicker. So that, did my y-intercept change at all? It has the same y-intercept, it has the same horizontal asymptote, but the effect of the b, that base, changes the graph at a faster or slower rate. What if I have a fraction, something smaller than 2, like 1.3? Then it'll go out a little slower.
Does it ever cross
the y line? We'll talk about that as we move through the lesson. Yes, it will. Let's go on to part B. Question 2. Now we're changing it to 2x plus 1 and 2 to the x minus 2. What's going to happen to our graph with the same parent function, 2 to the x? Okay, what happened there? What does the plus 1 tell us to do? That's moving it, transforming it up. And what's this one doing? Down. So now has my horizontal asymptote changed? Yes, my horizontal asymptote now is up 1 unit, or my horizontal asymptote is down 2 units from its parent function. So that does change my graph. So we just kind of answered a couple questions there. What effect? Does it change its shape at all? No. Okay, let's go on to question 3. Same parent function again, but now notice the difference. It's now in the power. Let's just do 2 of those. 2 raised to the x minus 1 and 2 raised to the x plus 2. What happens when they go minus 1 and plus 2? So we're doing 2 raised to the x minus 1. You might want to throw parentheses there. Just graph that one. Where did that second graph now move to? It's going to move it which direction? It's x to the minus 1. These are what I say, think opposite. So which direction did it move it? To the right one. So if I skip this next one, what do you think the other one's going to do? It's going to go which direction? Left 2. Okay.
It's just a curve.
It's the same curve, it's just going to pick it up and move this one to the right one. This is going to move it to the left 2. So because it's in the power, yeah, it's inside the function, so we have to think opposite. Okay.
Is the y-intercept this one?
Pardon me?
Is the y-intercept
No, it's going to move it. Yep. Next one. We'll just talk about these. Now, here's my parent function again, but now my negative is inside the function. If it's inside the function, it's going to reflect it. It's going to reflect it about the y-axis. So if you want to practice graphing this one, it's going to reflect it about the y-axis. So normally my function would look like this. That's my parent function. It's going to reflect it. So I have the same asymptote. I have the same critical point, but now this would be right here. Pardon? Can't graph that one? Be careful, it has to be a negative. So it'll be 2 raised to the negative x. So there is now my new one reflected. Pardon me? Has error? We'll check yours. Okay, this slide you don't need to write down, but let's just talk about the base. If my base changes, it tells me how quickly or how slowly it graphs, increasing or decreasing. Part C, remember that was up there in the power? It's going to move it to the right or left. You have to think opposite. Part D is outside the function, it's at the end. Sometimes they trick you and throw it in front of the function. That would move it up or down. And then these are your reflections. And I like to show it on the next slide. So I'm going to stop the recording and we'll talk about that in a more advanced way.